Okay, welcome everybody. So we have been working with functions in R, and so that in this module, working with functions. And so if you want to open this Colab notebook, you can click on the link in the description of this video and work along. But now we're at this exciting point. I hope you're there feeling the excitement with me, where we can now define our own functions. Okay, we're not going to be limited by the functions that are built into R, but we can talk about how we can customize and define our own functions. So the syntax for defining your own functions in R is as follows. So first of all, you need to name your function something, and that can be whatever you like. So in this snippet of like code over here, I have given the function the name my function, but we assign it the same way using the same assignment operator with this arrow. But the way that we begin defining a function is with the function. So we say function, and then inside of parentheses, we would give a name for each of the required inputs or arguments. So you could give these names whatever you like. So for example, it could be mean and standard deviation, as we used with like the pnorm function. So you can give these things names whatever you like. They don't need to be arg1, arg2, and arg3. They typically are names of things that are descriptive of the input that you're asking for. So after you've named all of the inputs that are required in the function, then you put a set of curly braces. And then inside of the curly braces would be the lines of code, and it doesn't need to be a single line of code that you want your function to execute. And that's it. And then when you want to run your function, you would just say my function, and then name what values or vectors or data frames you want to input for each of the arguments, and then run it like we've been running functions earlier. So let's do an example. So for example, let's say we want to create our own function to calculate the mean of a vector, a numeric vector. So the way that we calculate the mean of a set of values, so let's say I have a vector x that has values x1, x2, all the way up to xn. Then right, the way that we would calculate the mean of the values in x is that we would add up all of the values in x, x1 plus x2 plus x3, all the way up to xn. I missed the plus sign over here. I'm going to just plop that in. And then we would divide the sum of all of the x values, divide that by n. We would divide that by the number of values in our vector. So in other words, we would take the sum of all of the xi's and divide that by n, the number of xi's that we have. So here's how we could define our own mean function in R. So I'm going to call my function my mean, just to give it a name other than mean, which is already defined in R. So this I could call whatever I like. I'm going to use this assignment operator. Okay, but now I begin defining the function with function. And over here, I would enter however many inputs are required, and I would name those inputs whatever I like. In this case, I just have one input, and it's a vector x, or I can name this whatever I like. So I don't need to call it x. I could have typed and named this input anything in the world that I want. Then I would enter my curly brace to start my code that's going to be executing this command, this function. So this function is going to execute the following things. It's going to take my input x, which is a vector, and it's going to calculate how many elements are in vector x. So it's going to calculate the length of that vector, and it's going to store that to n. Then it's going to calculate the mean by taking the sum of all of the values in x. So that's what sum x does. So sum x is a function itself that you input a vector, a numeric vector x, and sum adds up all of the values inside of vector x. So that's doing the sum in the numerator, and then we're going to divide by n, where I defined n as the length of x. And then I want to see what that result is. So I want to make sure then that I print that result to the screen. So that's what this last piece is going. So you can imagine, like, anytime I run my mean, it's like in a code cell, I run these 3 lines of code. It's going to take x, calculate its length, take the sum of x, divide by its length, and then it's going to print that output to the screen. So when we run this code cell, nothing happened here because all we did was define this function. And let me just say that, there are different ways that you could do this. So let me just define a second way of doing this. I'll call it my mean2. And so you can see, like, as I'm typing this, it kind of does the typesetting a little bit for me. So if you kind of missed that, I just said my mean2 assignment operator function s, I hit a space. When I type the left curly brace, it automatically completed and closed it with the right curly brace. I want to type my commands somewhere, so I'm going to hit return so I have some place to type my commands, and then it moved it all the way down, to the bottom. So now I have some place where I can type my commands. And so over here, I could do something like I did over here. There's no reason why I had to, like, intermittently calculate n along the way, right? So I could have also done it just like this. So all I'm saying is there's not like one way to define these functions. There are lots of ways that you can do this. Some ways may be more efficient than other ways. This might be a slightly more efficient way, the way I did it here, because I'm not using any storage space to store the length of x anywhere. But I think that it's really using very minimal storage space. So either of these is just as efficient as the other, I would say. So anyway, there's not just one correct answer. If you're working on homework problems like this, there are lots of different ways that you could answer these questions and define these functions. Okay, so let's check our work real quickly in question 2 with how we define these functions. So in order for question 2 to work, it's going to have us check our mean, my mean function, to make sure it's working, comparing it with the built-in mean function using the birth weight samples that we created earlier in this question 1C. So if you want question 2 to work, just be sure that you run the solution in question 1C. So if you haven't run this code cell in question 1C, you might just want to take a look at the code that I've entered over here, do something similar, run this. And if you have a slightly different sample, if you haven't set the seed and you have a different sample, that's not a big deal. What is important is whatever you have stored in birth weight, when you come down here, you calculate the mean of your sample birth weights, whatever you get, you might get something different from me if you have a different random sample that was generated. But the mean that you get from your myMean function, this should be the same exact mean that you get from the built-in mean function. So I can see that the function that I defined above is giving me the same exact result as the built-in mean function in R. And I think that hopefully the other way that I define this function is also giving me the same exact thing. So this looks great. The function I defined up here is doing the same exact thing that the built-in mean function is doing. And again, if you did not set the seed when you created your random sample of 20 birth weights, you might have a different sample of birth weights that might have a different mean. That's fine. But these two code cells should be consistent with each other. So even if you're inconsistent with my output, the outputs of your two code cells over here, they should be consistent with each other. And just notice that my sample mean here is not exactly the same as the population mean, which was 3,500. And that's just because we picked one random sample of 20 values. That one sample, right, is not necessarily going to have the same exact mean as the population, but it's pretty close to it. So that makes sense. Okay, so we wrote a function to calculate a sample mean. That function seems to be working well, so that is great. In the next video, we're going to write up another function for a more complicated calculation. Okay, so we'll stop this video here and pick up in the next video with another function next.